So welcome back once again. We are in chapter carbon and its compounds, and we are in topic functional groups. And here if you observe concept nomenclature. What is meant by nomenclature of carbon compounds? It is simple naming ceremony, right? So if a baby is born, we'll keep some names for the baby, right? Same like that, if any new carbon compound is formed by these functional groups, by adding these functional groups, new chemical compound, new carbon compound is formed. For that carbon compound, we have to put some name. That naming ceremony is nothing but nomenclature. In simple words, okay? So for your 10th standard, that meaning is enough. Okay, then what we have discussed in last lecture, there will be carbon compound. For carbon compounds, we can remove one hydrogen and functional groups can be added to that. After adding functional group, properties of the carbon compound will change. There are 5 functional groups mainly in your 10th class: halo, alcohol, aldehyde, ketone, carboxylic acid. While coming to halogens, chloro, that can be mentioned like bond Cl, bromine bond Br, iodine bond I, like that you can mention. And next, alcohol. So if you want to add alcohol functional group, you have to remove one hydrogen and add OH, bond OH. I mean, in place of hydrogen, OH to be added. While coming to aldehyde, there will be carbon, and for carbon there will be 4 valency. We know that one already there, which will be combining with hydrogen or carbon, etc. Second bond, hydrogen will be present, and remaining 2 oxygen. You can draw with this angle, or you can draw like this also: carbon, single bond hydrogen, double bond oxygen. Like that also you can draw it. It is not compulsory for you to draw with this angle. Fine. Next, ketone, carbon, bond either sides. Definitely there will be carbon only here, and for the middle carbon, double bond O. If you represent, it is ketone functional group. I'll tell you, I'll explain each and every compound, no problem. Just try to know it. Carboxylic acid, bond C, 4 bonds should be there, already one is present. 2 bonds, oxygen will be filled here. 4th bond, hydroxide. So in this lecture, we are going to see alcohol functional group, aldehyde functional group, ketone functional group, carboxylic functional group. In previous lecture, we have seen halo functional group, chlorine, bromine, iodine. And I told you while you are naming, there should be prefix and suffix. And here, prefix means that chloro, bromo, iodo, those names will come in the front of the compound. Suffix means names will come at the end, in the last. So in last lecture, we have seen about halogens, that is bond Cl, chloro, bond Br, bromo, bond I, iodo, which is front, and we have named few also. So first, how we took? If you have carbon 1, 2, 3 carbons with all single bonds, I told it is applicable for alkanes. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens we can mention, and here hydrogen can be removed and chlorine can be added. Chlorine means it is halo functional group. When chlorine is added, how to name? So try to remember, only for the halogen it is front. I mean, while you are naming, that name should come front. Chloro, and you have to assume that there is hydrogen. You have to assume in your mind there is hydrogen. If there is hydrogen, what would be the name of the structure? Meth, eth, prop, all single bonds, propane. So chloropropane. Same like that, in place of hydrogen, if bromine is kept, Bromine, it is halo functional group. For halo functional group, that should be front. So what we can take? Bromo propane. Same like that we have named. If you take one carbon with 4 hydrogens and one hydrogen is removed and iodine is added, iodine is halo. So if iodine is present, it should be named as iodo. And you have to think in your mind that there is hydrogen. If there is hydrogen, what is this structure called? So CH4, it is called meth. So methane. And if you see this, if bromine is kept, it is not compulsory that you have to keep bromine here only. You can place it here, you can place it here, you can place here, wherever it may be. One hydrogen can be removed and one halo can be added. So bromine, if you keep it, it becomes bromo. How many carbons? Meth, ethane, like that. So like that we'll get bromomethane, bromoethane, bromopropane, bromobutane, bromopentane, bromohexane, etc. From chloromethane, chloroethane, chloropropane, chlorobutane, chloropentane, chlorohexane, etc. From iodo also we'll get iodomethane, iodoethane, iodopropane, iodobutane, iodopentane, iodohexane we will get. Like that we can draw, we can name, we can write formulas. And I told you to go with this in last lecture, chloropentane and bromohexane iodopropane. I told for chloropentane. Now, I hope you did this work. If not, you can check it now. First, bromohexane. Try to draw hexane. Hexane means how many carbons? Meth, eth, prop, but, pent, hex, 6. 1, 2, 3, 4, 5, 6. Always carbon should be added first, represented first, and it is ane. Ane in the sense it is alkane. Alkane means all single bonds between carbon, single bond between carbon, and all carbon should satisfy 4 valency, like that. 4 valencies, and you have to mention, represent hydrogens everywhere except 1. So represent all hydrogens, whatever it may be the place you want, you can leave. If you want, you can keep it here also, no problem. Okay. So, or you can keep it here, no issues. So hydrogen, and here what they asked, bromo. Bromo means you have to add Br. Now it becomes bromohexane, like that. And iodopropane, meth, eth, prop. It is ane. Ane means single bonds, and 4 valencies should be satisfied and hydrogens to be represented. And here iodo means iodine, I. Like that you have to represent functional groups related to halogens, chloro, bromo, iodo, etc. Now we are done with one part. And now let us try to understand alcohol, aldehyde, ketone, and carboxylic acid. Okay, first let us take propane. Propane. So you know how to draw propane. Meth, eth, prop. It is ane. So single bonds, and carbon should satisfy 4 valency. For first carbon 4, for second carbon already 2 is there, 3, 4. For third carbon already 1 is there, 2, 3, 4. To draw propane, what we have to do? We have to represent all hydrogens. Like this we will represent hydrogen. Now it is propane. Now it is propane. Consider we removed one hydrogen here, and if you add, you see the first one, alcohol. Alcohol means bond OH, isn't it? So if you represent, already bond is there, no need to draw any extra bond, guys. Okay, don't draw extra bond like this. No, you should not. Already bond is present. So if you represent OH. Now it is not propane. It is not propane. Okay. It is new chemical formula. It is new carbon compound. We have to give new name, nomenclature to be followed, prescribed by IUPAC, International Union for Pure and Applied Chemistry. How to name? So first step here, there are steps. Identify the number of carbon atoms in a compound. So first what we have to do, we have to identify number of carbon atoms in a compound. A compound having 3 carbon atom would have the name propane. Okay, for example, so first what we have to do, we have to count number of carbons. 1, 2, 3. So that is the first point. Count number of carbons. How many carbons are there? 3. If it is 3, meth, eth, prop. So we will get prop or propane. If we assume that hydrogen is present, right? If we assume that hydrogen is present, we can call it as propane. Okay, what is the second point? In case a functional group is present, yes, now functional group is present. What functional group is present? Bond OH functional group is present. Yes, it is present. It is indicated in the name of the compound. So if any functional group is present, that should be indicated in the name of the compound. So in propane, that functional group should be named. We have to add. Okay, how to add? Either prefix or suffix. Okay, prefix or suffix. You see, if you observe this table, only for the halogen it is prefix. And what are the things we are learning today? Alcohol, aldehyde, ketone, carboxylic acid, all are suffix. Suffix. Suffix means it should be last. Okay. If alcohol functional group is present, what to call this? OL, all. Okay. If alcohol functional group is present, that should be suffix, and that is all. Now, okay, that is the second point, right? What is the second point in short? Naming functional group. What functional group is present? Bond OH. Bond OH means alcohol. So what is the shortcut of the alcohol? OL, all. So last 2 letters, OL, all we will take. So second point is done. So this OL should be present in the propane. How to do, we will see. Let us take third point. If the name of the functional group is to be given as suffix, so yes, we are going with suffix only right now. The name of the carbon chain is modified. So it is basically propane because of 3 carbons, and there is one functional group that is OH is present. OH is nothing but it is alcohol. So if alcohol is present, that is mentioned as OL, and that is also suffix. Okay. If the name of the functional is to be given suffix, then what to do? The name of the carbon chain. So this is the name of the carbon chain, right? Propane. That carbon chain name is modified. How it is modified? By deleting the final E. So you can see PROPANE spelling. Final E is there, right? That should be removed. That should be removed. That should delete. And adding the appropriate suffix. So what is the suffix of alcohol? OL. That OL to be added here by removing E. So it will become PROPAN. E is deleted. OL we will add. It will become propanol. Propanol. Right? For example, a 3 carbon chain with ketone. Yes, we will see next example, that ketone. If ketone is present, guys, what we have to do? If a 3 carbon means it is propane, PROPANE, propane. E to be deleted. If ketone is present, ketone, what is the shortcut of the ketone? Here we can observe for ketone, it is ONE, not one. Known, it is own. You should not call it as ONE1, TWO2. No, it is not. You are not learning second class mathematics. It is ketone, ketone, own. So appropriate suffix to be added for ketone, it is own. So that own to be added for the propane and E to be deleted. If you delete and add, what it will become? Propanone. So propanone, like that. Fourth one, if the carbon chain is unsaturated. So till now we have seen for saturated. If it is unsaturated, then final ANE in the name of the carbon chain is substituted by ENE, YNE. So for saturated only we are adding functional groups. For unsaturated, we are not adding functional groups in your 10th class. Okay. So in your 10th class, we are seeing addition of these functional groups for only alkanes. Okay, let us see few examples. I will draw and let us try to name it. Okay, what is the third step they told? Remove E from the name of carbon chain and add appropriate suffix. Okay, then add appropriate suffix. Let us try to see examples. Now I will draw one. Okay, like that there is one carbon compound or hydrocarbon functional group compound is present. Now how to name? What is the first point? Count number of carbons. If you count number of carbons, it is 1. 1 means meth, right? Meth. All are single bonds, isn't it? So it is alkane. So ANE. So it is methane. What we have to do? We have to remove last letter E. Then observe what functional group is present. Bond OH is present. Bond OH means it is alcohol. What is the shortcut for the alcohol? OL. That OL to be added here. It will become methanol. Methanol. Okay, let us take another example. Now if you observe, so now easily you can identify and name it. How many carbons? 2. What are they? Meth, eth. So it is eth. In between carbons, single bond. So it is alkane, saturated, AN, E to be removed. And what functional group is present? Bond OH. Bond OH means alcohol. So it is ethanol. Same. You can draw for. Now in examinations, if they give propanol, already we have done. Butanol. They will ask you to draw butanol. How to draw butanol? Simple. So first 3 steps you have to see. First step BUT, second step AN, third step OL. So BUT means meth, eth, prop, but. 4. 1, 2, 3, 4. Here AN stands for alkane. Alkane means saturated. Saturated means single bond. So single bond between carbons. Next, carbons as usual that should be satisfied with 4 valencies. Okay, what we can do? Draw all hydrogens except one. Leave one space. One bond you can leave it. Now what is that last? OL. OL stands for alcohol. So what is the functional group of alcohol? Bond OH. Already bond is present, draw OH, done. Like that, you can get names of methanol, ethanol, propanol, butanol, pentanol, hexanol, and so on. So we have seen for alcohol. Now let us go for aldehyde. Before that, we have to know what is that aldehyde structure or formula. If you observe aldehyde, it is C will be as usual single bond H, double bond O, right? Single bond H, double bond O. Now let us see that this aldehyde, okay, for example, we have ethane. If I ask you to draw ethane, how can you draw? Meth, eth, single bond between carbon. Carbon should satisfy 4 valency. 1, 2, 3, 4 is already present. For this carbon, 1 already there, 2, 3, 4. And if you add hydrogens here, now if they ask you what is this carbon compound, what is this hydrocarbon compound, easily you can say it is 2 carbons, sorry, and single bond and all hydrogens, it is meth, eth, so it is ethane. You can say ethane. Okay, now what I will do, I will remove this hydrogen, I'll remove this hydrogen, and I'll remove one bond here, and I'll add that one bond here. Is there any wrong? If I add like this, one bond here, one bond here. No wrong. Why? Because if you observe for first carbon, it is satisfying 4 valencies. This first carbon needs 4 valency electrons. One is with this hydrogen, one is with this hydrogen, one with this hydrogen, one with this carbon. Satisfied. Well, coming to second one, for the second carbon, first valency here, second valency is here, 3, 4 valencies you are representing here, no problem in that. And add oxygen here, O. Now what we got? Structure, bond C, single bond H, double bond O, right? Single bond H and double bond O. It will become what? Aldehyde, right? Aldehyde. Aldehyde. It is functional group, and aldehyde representation shortcut is Al. For the alcohol, last 2 letters they took OL. For aldehyde, it is first 2 letters Al, and this Al should be suffix. Suffix means last. Now try to name. Now this is not ethane, right? This structure is not ethane. Now how to name the structure? First, count number of carbons. 1, 2 means meth, eth. ETH, eth. In between carbons, only in between carbons, single bond only there. Don't consider this double bond. This double bond is between carbon and oxygen, but in between carbon, single bond. Single bond means AN. AN. Now, what is this structure? This structure is, this functional group is aldehyde. Aldehyde means Al. It will become Al. So you can call this one as ethanol. Ethanol is different. Ethanol is different. Are you getting it? Ethanol is different. Ethanol is different. Now, can we do it with one carbon? Let us check. Carbon should have 4 valencies. 1, 2, 3, 4. Hydrogen, hydrogen, oxygen. Yes, got satisfied. It is bonded. And now how to represent name? How many carbons? 1. 1 means meth. And only one carbon, no bonds, leave it. Okay. Double bond is between carbon and oxygen, we should not consider. So it is alkane group, AN. And we have added aldehyde functional group, aldehyde shortcut AL, it will become methanol. And they will ask you to draw for propanol. Propanol. So propanol means we have 3 divisions. First division, prop. Second division, an. Third division, all. Prop means meth, eth, prop. Done. Second one, an. An means alkane. An means alkane. Alkane means single bond. In between, only carbons. Single bond, single bond. Now, it should satisfy 4 valencies. But before that, what you can do here, you see last, Al. Al means definitely we know double bond O, single bond H. Right? By seeing that one itself, we can draw it, double bond O, single bond H. And now it should be satisfied. Last carbon satisfied with 4. Middle carbon, 1, 2 bonds are already there, 3, 4. Third one, 1 is already there, 2, 3, 4. Now represent hydrogens everywhere. That's it. Now this chemical compound is propanol. Not propanol, it is propanol. Now, if they draw like this, what we can say? 1, 2, 3, 4, 5 with single bonds between carbon, and at last we have double bond O and single bond H, and here and all hydrogens we have. Now it is meth, eth, prop, but, pent. Pent. All single bonds between carbon. Alkane, An. Here the functional group is aldehyde. So Al, it will become pentanol. Right? So here what we got? Methanol, ethanol, propanol, butanol, pentanol, hexanol, etc. Right? Methanol is different from methanol. Next functional group, ketone. Right? Next functional group is ketone. Ketone, how to represent with? On. That is suffix. What is the structure? Carbon, bond, bond, for middle carbon, double bond O. This side and this side, definitely carbon should be present. Now, this ketone is not applicable for meth and eth. Why? Because this side carbon should be present, this side carbon should be present. Middle, it is obviously it is carbon. How many carbons are there? 3 carbons. Meth means 1 carbon, eth means 2 carbons. So with 1 or 2 carbons, you cannot get ketone. So you cannot get methanol, ethanol. No, it is not possible. It is not possible to get methanol, ethanol. But from propanol we can get. So let us see. Carbon, 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 single bonds between carbon. For the middle carbon, it is double bond O, and satisfy valencies. For first carbon, 1 is there, 2, 3, 4. For second carbon, 1, 2, 3, 4 satisfied. For third carbon, 1 is already there, 2, 3, 4. Now mention hydrogens wherever there is single bond. Now, if they ask you to write the name, what to write? Meth, eth, prop. So it is prop. In between carbons single bond. So alkane, AN, E to be removed. And what is the structure? Ketone. Ketone means one. So it is ONE. It will become propanone. Propanone. Right. If they ask you to draw butanone, butanone, how to draw butanone? Meth, eth, prop, but. Right? Meth, eth, prop, but. Single bonds between carbons. And it is, so but means 4 carbons. An means it is alkane, simply to say single bond. One means for carbon there should be double bond, but what we have to remember, this side and this side there should be carbon. So that is applicable for this carbon or this carbon. You can draw double bond O here, correct, or double bond O here, correct, but it is not applicable for this and this. Why? Because here we will get one bond, but that is definitely hydrogen. Here we will get one bond, that is definitely hydrogen, right? So it is not applicable for these places. So how we can draw now? Meth, eth, prop, but, single bonds between carbons and double bond. It's your wish, either here or here. So you can draw here double bond O. Now it should satisfy 4 valencies. For first carbon, 1 already there, 2, 3, 4. For second carbon, 1, 2, 3, 4 satisfied. For third carbon, 1, 2 already there, 3, 4. For fourth carbon, 1 already there, 2, 3, 4. Now represent hydrogens wherever you see single bonds. Now the name is meth, eth, prop, but. But in between carbon single bonds, and functional group is double bond O for the carbon which is in between 2 carbons, that is ketone one, butanone. So like that you can draw. So methanone, ethanone is not there. Pentanone you can draw, sorry, not pentanone, it is propanone. Propanone, butanone, pentanone, hexanone, like that you can keep on drawing. And last one, carboxylic acid. If you see this carboxylic acid, what is the structure they gave? Double bond O, single bond OH. So for that, what we have to call it is oic acid. Oic acid, we'll see. It is double bond O, single bond OH. Carboxylic acid, and the short form is oic acid, and it is suffix. Suffix means last or at the end. Structure, carbon will be present, double bond O, single bond OH. Now I'll draw one structure. 1, 2, 3 carbons. In between carbons single bond. All carbons will satisfy 4 valencies. And if I draw hydrogens near the single bonds, what would be the name of this carbon compound? Meth, eth, prop. So it is prop, all single bonds, an, no functional group, E, right? If there is no functional group, it is propane. If there is functional group, we have to remove E. Okay. Now what we can do? Let us remove this hydrogen and let us remove this hydrogen. Let us remove this third hydrogen. 3 hydrogens we have removed, and let us remove this bond. Let us do few modifications. Let us draw another bond here. So there are 2 bonds. Is there any problem with the valency? No problem with the valency. Now let us add OH instead of hydrogen and oxygen here. So double bond O, single bond OH. That's it, right? If you observe the table, it is double bond O, single bond OH. So now, what would be the name? First, we have to count number of carbons. Meth, eth, prop. It is prop. Single bonds between carbon. It is alkane, ANE. It is propane. But functional group is present. If functional group is present, E should be removed. And we have to add that respective functional group. What is that functional group? Carboxylic acid. But what is the short form? Oic acid. So it will become oic acid. So answer is propanoic acid. Propanoic acid. I'll draw another example. You can get that carbon, 4 valencies, 1, 2, 3, 4. Satisfied. Hydrogen, hydroxide, oxygen. Now, so how many carbons? 1 carbon. It is meth and it is alkane. So AN. What functional group is present? Bond OH, double bond O. Okay, so bond OH, double bond O, it is carboxylic acid. It will become methanoic acid. Now you will get idea if I draw another. Carbon, carbon, single bond between carbon, here double bond, here single bond OH, double bond O, single, so it is satisfied. If you draw, it will become 5. So 5 is not correct one. So hydrogen here, hydrogen here, hydrogen here. Now, if they ask you, go with the name. So count meth, eth. It is eth. Single bond between carbon, alkane, an. It is double bond O, single bond OH. It is carboxylic. So it is oic acid. It is becoming ethanoic acid. Now, if they ask you to draw butanoic acid, how to draw that butanoic acid? 3 parts. First part, but. Second part, an. Third part, oic acid. But means 4 carbons. An means alkane. Alkane means single bond. Oic acid means carbon, double bond O and single bond H. Let us combine all together. First 4 carbons. 1, 2, 3, 4. Second one, single bond between carbons. Single bond, single bond, single bond. That's it. Next, satisfy valency. Before that, what we can do? You can add oic acid. Double bond O, single bond OH. Now, if you observe this 4th carbon, valency 4 satisfied. Third carbon, 2, 3, 4. Second carbon, 2, 3, 4. First carbon, 1, 2, 3, 4. Add all hydrogens. That's it. We got butanoic acid. So like that, we can write for methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, and we get hexanoic acid too, and so on. It will be continuing. Hept, octa, sept, octa, nano, deca, it will be going on. So in this lecture, we have seen how to draw, how to write, how to represent, how to name methanol. You see what we have seen: methanol, ethanol, propanol, butanol, pentanol, hexanol, methanol or ethanol, propanol, butanol, pentanol, hexanol. Methanol, ethanol is not possible because we need to get double bond O with 3 carbons, and 1 carbon should be between. Propanone, butanone, pentanone, hexanone, methanoic acid, ethanoic acid, propanoic acid, butanoic acid, pentanoic acid, hexanoic acid. Now you are very familiar with nomenclature. So if it is alcohol bond OH, it is aldehyde carbon bond H double bond O. If it is ketone, carbon with double bond O, and definitely there should be carbons either side. Carboxylic acid, carbon single bond OH, double bond O. So these are the things which I have learned, and in last lecture we have seen halo. Halo means we have chloro, bromo, iodo. Chloro means bond Cl, bromo bond Br, iodo bond I, and this halo will be prefix, and these all 4 will be suffix. And while coming to names, for alcohol it is OL, all. For aldehyde it is AL, all. Ketone it is ONE, all. For carboxylic it is oic acid. Like that we have got for all alkanes, all structures we have seen. You can practice once again such that there will be no doubts in that. In next lecture, I'll come up with different structures, and we will learn chemical properties of carbon compounds. That's it in this lecture.